Hi, everybody, and welcome to MAC 2233. This will be our first lecture, Lecture 1-1. And we're going to start off with talking about functions. So a function is a type of a relationship, okay? So a relationship is between an input, or what we call an independent variable, and an output, which we also call a dependent variable. For example, we have an ordered pair, x comma y, that is a relationship. Now, if we want to talk about what is a function is a type of relationship that has an extra condition. That condition is that for every input value x, we can only have one output value y. And we say the output is a function of the input. Let's talk about function notation, and then we'll get into how to decide if something is a function. So function notation, the notation output is that f of the input defines a function named f. This would be read, output is f of input. Again, that's not very clear, so let's keep reading. To simplify, there we go. Writing out expressions and equations involving functions, a simplified notation is often used. We also use descriptive variables to help us remember the meaning of the quantities of the problem. So we can say H is F of A. Or we can say H equals F of A. We could instead name the function h and write h of a. So what does all that really mean? Let's get into what we're talking about. So if we have a function, and let's say, let's use h of a. Why would I use h of a? Or let's use h of x for our case, okay? Now, why did I choose h? I chose h because I'm going to talk about this being the height. Okay? So now h actually makes some sense. So if I say h of x is equal to 2, what I'm saying is that my height, no matter what value I put in for my x, I get 2. Okay? Or I can say h of x is equal to 2 times x. And now I'm saying when x equals 1, so my ordered, here, let's draw a table first. Anybody, I don't want to confuse anybody right from the start. So let's first start with a table. So when x equals 1, I plug in 1 for x, I get h equals 2. If I say x equals 2, I plug that in, and I'm basically plugging it in right here. 2 times 2 is 4. When x equals 3, 2 times 3 is 6, and so on, okay? So now we have created a function. Whenever I put in a value of x, I get out a value for my height, okay? So I don't want to get too detailed yet. We'll get more detailed soon, but that's basically what we're talking about. So I would read this as h of x equals, and then whatever my function is, okay? This is my input, and this is my output, okay? All right, let's continue on. So we have these tables, and we want to know which of these defines a function. This goes to 1, this goes to 3, and 8 goes to 6, okay? So I input 2, out comes 1. I input 5, out comes 3. I input 8, out comes 6. So if I were to write it a different way, which maybe would be easier for us to understand, maybe not for this first one, but for the ones coming up. And I only want one of each of the values. Okay. So again, I input 2, out comes 1. I input 5, out comes 3. I input 8, out comes 6. Okay. For every input, there's a different value for my output. So this is a function. Okay. Let's do it again for this one. And then I think I'm going to give you an example, like a more real life situation that I think you'll understand. So let's say I have my input is 3, 0, 4. And notice I only have 2 different outputs now, 5 and 1. Remember I said only do 1 for each. So I input 3, a -3, out comes 5. I input 0, out comes 1. Now here, I'm going to input 4, and out comes 5. So is this a function? Well, this is also a function. Why is this a function? Because for every input, I only have one output. Okay. And let's do the last one, and then I'm going to make it more real life. So the last one is, here's my input, here's my output. 1, 5. Remember, I'm only going to put 1, 5. And I have 0, 2, 4. So when I input 1, out comes 0. I input 5, out comes 2. I input 5, out comes 4. This is not a function. This is not a function. Because notice for input 5, I have 2 different outputs. Well, which one's correct? I don't know, right? So imagine, let's see, imagine these are cell phones, okay? So I'm going to use the same example, I think. I can use the same example for this. Let's see. So my input is cell phone numbers, and my output is people that they belong to. Okay. Same here. Cell phone people, cell phone people. I'll even make it better. Okay. So let's say this is John, Mary, and Susan. Okay. I hit 2, I get John. I hit 5, I get Mary. I hit 8, I get Susan. Perfect. Just like a phone should work, right? Second example. John, Mary, Susan. I hit -3. I know that sounds weird. And I get John. Perfect. I hit 0, I get Mary. Not a problem there. I hit 4, I get John. That's not a problem, because I can assign 2 different buttons to John, can't I? John could be -3 and 4. It doesn't matter. As long as when I press that button, I get one person, I'm happy. And I get the person I'm expecting. let's look at this last one. John, Mary, Susan. Actually, yes. Okay. So I press button 1, I get John. I press button 5. Who's going to answer the phone? I have no idea. That's not a function because when I press 5, I want to know exactly who I'm going to speak with, don't I? And here, it's just kind of like whoever maybe the phone decides to call. That may not be what you planned, which is why that's not really a function. So hopefully that helped explain all of that. Okay, let's continue on. So solving and evaluating functions. When we work with functions, there are two typical things we do: evaluate and solve. Evaluating a function is what we do when we know an input and use the function to determine the corresponding output. Evaluating will always produce one result, just like we saw, since each input of a function corresponds to exactly one output. Solving equations involving a function is what we do when we know an output and use the function to determine the inputs that would produce that output. Solving a function could produce more than one solution, since different inputs can produce the same output. So just like we saw before, different inputs can produce the same output. But we don't want one input to have two different outputs. So let's look at this. We want to evaluate, so it says using the table shown where Q equals G of N. So let's talk about this notation first. Here we have G of N. Okay, so if I say G of N equals G of 3, and actually do this. Then we can see that what we're really saying is N has to equal 3. So we come over here to my N. N is 3. I find my Q. Q is 7. And so when I evaluate this, I'm saying this equals 7 since Q of N, since G of N is equal to Q. So hopefully that made sense. Okay, now let's do it a different way. Now I'm saying Q, which equals G of N, equals 6. So Q equals 6, that's right here. And I want to know what is N. I'm asking what input do I have to put into this function to produce 6 as an output? And I look here at my N, and my N is equal to 2. I could also say now that G of 2 is equal to 6. Okay? So that's how we can read functions on tables. We can also have graphs as functions. So often a graph of a relationship can be used to define a function because we said, we can use x comma y. By convention, graphs are typically created with the input quantity along the horizontal. So we usually use x along here It doesn't have to be X. As a matter of fact, the one we used before was N. So if I look at my last question, the horizontal axis had ends. And our vertical axis here, it says y equals f of x. So this is y. Y is a function of x, our input. So y is our output. Our input is x. For the previous question, let me do this. Let's put this here. And for the previous question, this would be Q. I just want to put them in the same color so you can see that they go together, and we call this G of N. Okay, so it all matches. So we have these three graphs, and we want to know, can we tell whether or not something is a function just by looking at a graph? And the answer is yes, we can. When x equals 1, this is my x value. I'm right here, and I go find where on the graph it hits, and it hits right there. So this is f of 1. Because my input is 1, my output is my y value, my function of my function when x equals 1. And we can say that is equal to -3. And I can go everywhere along here, and there's nowhere here that I'm going to find, no matter what I pick, two values for the same x, even if I go right here, right? I go up to here, and there's one value. That's it. The same is true for the middle graph. Okay? However, it's not true in this last graph. Okay. For example, if I say x equals 1, I'll be right here. Uh-oh, I'm confused. Is this my point or is this my point? I have two different points. I don't know which one to pick. That's because for this input, there's two separate outputs. And there's two separate outputs everywhere. Everywhere, no matter what value I pick, there's going to be two values, except for one place, which is right here. Because here, there's 1 point, and it's y equals 0. But this is still not a function. So this is a function. This is a function. This is not a function. Okay? So we're going to talk now about, an easy way to do it. It's called the vertical line test. And it's a handy way to think about whether a graph defines the vertical output as a function of the horizontal input. In other words, saying the vertical line test basically just tells me if I have a function, okay? Imagine drawing vertical lines through the graph. If any vertical line crosses the graph more than once, then the graph does not define, a function, okay? For example, let's go back and look, let's make up another one. So let's say I have a graph that looks like this. Well, I can put a vertical line anywhere. And notice it's only going through one point. Doesn't matter where I put it. It's going to only go through one point. But what if I draw a graph that looks like that? Well, this is definitely not a function, because if I put a vertical line here, it's going through 2 points. If I put a vertical line here, it's going through 2 points. Even though everywhere else, or in many other places, it's only going through 1 point. If ever it goes through 2 points, we can automatically say it's not a function. If only one place it goes through 2 points, it's not a function. Okay? So if we look back at the last graphs, we can do the same. This would not pass the vertical line test because there's 2 points on that vertical line, and so on. This would pass the vertical line test. There's no place I could put a vertical line where I pass through 2 points, and the same with the first graph. Hopefully that's clear. Okay, so given this graph here, we want to find first f of 2. What does that mean? Well, if I know that f of x is equal to some function, this looks like a parabola, so let's call it x squared. It's actually, if I were to tell you what it is, it's actually x minus 1 squared. Okay? Okay, so a nice simple way to figure out what this is asking for is they're asking for f of 2, aren't they? So here's what I'm gonna show you this little trick that I really like. This just makes it a little clearer, I believe, to understand. So here's f. I'm just gonna rewrite everything exactly the same way, here and here. Okay. Now, this was x, and this is x. Now, everywhere that I have an x here, I'm going to now replace the x, because I'm looking at this with a 2. Because I want to know what f of 2 is, right? Well, it's replacing the x's, isn't it? So f of 2 is going to equal 2 minus 1, which is 1, squared, which is equal to 1. So f of 2 equals 1. Look at that. F of 2 equals 1. When I plug in 2 for x, so this basically means x equals 2, y equals 1, or we can put in ordered pair form 2, 1. Okay? Now, I want to know, it says, next one says, f of x equals 4. Okay, well, that's a little different, isn't it? Because I said f of x is equal to x minus 1 squared. And they're telling me that this is equal to 4. So really, I already know what my y value is, because remember, my function is really like my y. So I already know what my y value is. I need to find my x value. So what I can do is I can go here and find where y equals 4. And I go horizontally, and I see here and here, both of those places, I can see that y equals 4, can't I? Well, now I can just read my x values. When x equals 3, y equals 4. And also when x equals -1, y equals 4. So I have two places that y equals 4, but it's still a function because I know when I plug in 3, out comes 4, and I know when I plug in -1, out comes 4. Let's just test this and see if it's true. So I have y equals, well, I have 3 minus 1 squared, which equals 2 squared, which equals 4. Perfect. And here I have y equals -1 minus 1 squared, which is equal to -2 squared, which is equal to 4. Look at that. Perfect. So you have to just see the difference. It's very important to see the difference between what they're asking for. Here so for A, I know X and I need Y. For B, I know Y and I'm looking for X. Okay? So we can also have formulas as functions. So when possible, like I just actually made that formula up. When possible, it is very convenient to define relationships using formulas. If it is possible to express the output as a formula involving the input quantity, then we can define a function. So here we have express the relationship 2n plus 6p equals 12 as a function p equals f of n. Okay, so what are they actually asking me? They want to know f of n, okay, which is we're going to call p. So we want to solve this function for p, and then we're going to get p as a function of n. So let's do it and you'll see what I mean. We start with 2n plus 6p equals 12. Then we're going to subtract 2n from both sides. This cancels, and we end with 6p equals 12 minus 2n. But we're still not, we want to find p equals. So we're going to divide both sides by 6. And you can also just say you're going to divide each thing by 6. So the 6's cancel, and I get p is equal to 12 divided by 6 is 2, minus, 2 divided by 6 is 1/3, or I can cancel this to a 1 and this to a 3, and I get 1/3 times n, or n over 3. Both means the same. Now, look, I know what p equals, and we just said p is a function of n, so we can say f of n is equal to 2 minus 1/3 n. And here's what I want you to notice, that this independent variable input has to be the same letter as the independent variable or the input on the other side. If I were to say f of triangle, it's going to equal 2 minus 1/3 times triangle. Notice these are the same. The second is f as a function of a triangle, which I know doesn't make sense to you, but I'm trying to show you that those have to match. That's what we're looking for when we say something is a function of something else. Okay? I'm hoping this is clear. If not, just let me know. You can always send me requests. You can come to my office hours. If you can't make my office hours, just send me an email and say, I don't understand this. And, either I can try to explain it in writing, or I could make a little Zoom thing for you, or you can meet me on Zoom and I can explain it. I don't mind doing a little tutoring here and there whenever you need it. So just let me know. Okay. Getting back to this, given the function k of t equals t cubed plus 2, notice, here, let me make this a little bigger. Notice again, t is a function of t. Okay? So we have evaluate k of 2. So again, if I say k of, and everywhere I have a t, instead of putting a t, I put parentheses. I'm going to write it twice. Okay, so notice wherever I have a t here, I just left parentheses. And here, I'm going to put the t in. But for a, I'm going to put 2 in. Now I can evaluate this. 2 to the third power is 2 times 2 times 2, which is 8. 8 plus 2 equals 10. K of 2 equals 10. Period. That's it. Okay. Now, so this is A. Let's do B. It's telling me K of T equals 1. And that equals T to the third plus 2. Okay, so I can rewrite this as T to the third power plus 2 equals 1. I subtract 2 from both sides. I get t to the third, let's cancel, equals -1. I can take the cube root of both sides. That cancels those, and I end up with t equals the cube root of -1, which equals -1, because -1 times -1 equals +1 times -1 equals -1. So my answer here is t equals -1. If I plug that in to my original function, out will come +1. And that's how we do it.